Let's start with the graph f of x equals x squared. We will find the function values that are associated with the x values -2, -1, 0, 1, and 2. We will find the function values by squaring each of the x values. So when we square -2, the result is 4. When we square -1, the result is 1, and so on. When we graph this function, the result is a parabola. Now let's look at the graph of f of x equals the square of x plus 2. The important thing to note here is that 2 will be added to each x value before that quantity is squared. In order to compensate for the addition of 2 units to each of the x values, we will subtract 2 from each of the x values in our previous function. We do that so that the y values will be the same. So when we graph it, we can see that the graph of f of x equals the square of x plus 2 is shifted 2 units to the left of the graph of the function f of x equals x squared. Now let's subtract 2 from x before we square. This time we will compensate for this subtraction of 2 units by adding 2 units to each of the x values in our original function. Again, we do this so that the function values will match. And we can see a clear shift of 2 units to the right from the original function. So now let's state some generalizations about horizontal shifts. Suppose that a constant c is greater than 0. To graph y equals f of x plus c, shift the graph of y equals f of x to the left c units. In this case, the constant c was 2. To graph y equals f of x minus c, shift the graph of y equals f of x to the right c units. Again, in our example, c was 2.